This video is on counting significant figures and also dealing with some rounding. So in our previous lesson, we have learned what significant figures are. Of course, they're all the known values plus the estimated digit in a number. And we also learned how to read some measuring devices and to the correct number of sig figs. So this lesson will be, if you're just looking at a number that was written down, how do you know which of the digits are significant? And then also dealing with some, like I said, some rounding issues. Okay, so rules for counting significant figures. So here we go. So rule 1, all non-zero numbers are significant. Okay, so if you come across a measurement, as an example, that says 1.25 meters, okay, then this 1, the 2, and the 5, because they're all non-zero, right, they're all numbers that aren't zero, this number would have 3 sig figs. Okay, so it's as easy as that. If they're non-zero numbers, life is easy. So all my other rules are about zeros. Okay, so the second rule is something, I call them sandwiched zeros. And sandwiched zeros are significant. What do I mean by a sandwiched zero? Well, something like this. 406 inches. All right, so that 0 is sandwiched between 2 other sig figs, the 4 and the 6, making it also significant. So this number has 3 sig figs, and I'm just circling it to show you that that's the number of sig figs. Okay, now you can have multiple sandwiched zeros, which is sometimes confusing for students. You can also have zeros sandwiched over a decimal point. So something like, let's see, something like 1005. Okay, that has 2 sandwiched zeros, but both of those zeros are significant. So making this number have 4 sig figs. And then you can also, like I said, sandwich over a decimal. So let's do 60.002. Okay, so if that was the number, it doesn't matter that I've sandwiched all those zeros. This is significant, and they're all sandwiched between, so this number would have 5 sig figs. Okay, so those are sandwiched zeros. All right, my next rule is about something that I call leading zeros. And as you might guess, leading zeros come in front. Okay, so a leading zero comes in front of numbers, and leading zeros are most often, accompanied by a decimal point. So an example would be like 0.0045. Okay, well, those 3 zeros, even though there's a decimal point there, right, are leading. So they are not significant, but the 4 and the 5 are. So in this case, this number only has 2 sig figs. We don't really see leading zeros in front of numbers that aren't decimals, because think about it, like you wouldn't write 015 to be 15, right? So really you're only going to see it if it was with a decimal. So something like this, right? That decimal is still, that 0 is still a leading zero. And so that number only has 2 sig figs, the 1 and the 5. Okay, so if you're not a leading zero, then you're something that I refer to as a trailing zero. And trailing zeros are a little bit different. Oops. Sorry. Jeez. Clicking on the wrong things, guys. Sorry. Okay. So this idea of trailing zeros become significant only if there's a decimal point. Okay, so we have an only, here. So let's see, this is a trailing zero. 480. Okay, that zero is trailing because it's at the end of the number. So how many sig figs are in this number? Well, the 4, yes. The 8, yes. The 0 is trailing, and it says trailing zeros are significant only if there's a decimal point. Well, there's no decimal point in this number. So this number has 2 sig figs. Let's do another one. Okay, so what if we encounter the number 57.0? Well, the 5 is definitely significant, and so is the 7. And in this case, the 0 is significant. It's a trailing 0, but there's a decimal point. Makes it significant. So this number has 3 sig figs. Let's go back to that 480 number for a second, because the number 480 has 2 sig figs, but the number 480 point has 3 sig figs, because that 0 becomes significant with the addition of the decimal point. So sig figs and zeros get a little funky sometimes with the rules. And so we're going to do some practice. But I have 2 more rules real quick. I'm going to erase a couple of these examples so that I have more room. Okay, the 5th rule is an easy rule. And it says, in scientific notation, the number of digits in the coefficient are equal to the number of sig figs. And I will show you what I mean. So let's say you have the number 4.5 times 10 to the 3rd. Okay, you can write this out, and I'll do it in just a minute to prove it to you. But this rule says that in scientific notation, the number of digits in the coefficient are equal to how many sig figs there are. So what we mean by that is how many digits are right here, 2. That should be that there are 2 sig figs in this number. I don't even have to take it out of scientific notation. I will, though, because I want to prove it. So this number regular is 4500, right? 1, 2, 3, yeah. Which, if we go with our sig figs rules that we just learned, the 4 is significant and the 5 is significant, but those 2 zeros are not significant because there's no decimal. So again, we just proved that this rule is correct. So when you see scientific notation, you can take it out and then count, but I would recommend that you just count those digits out in front. It works every time. All right, and then rule 6 is kind of an interesting one, and it's going to come up when we do calculations. Rule 6 says, it talks about conversion. So remember, conversion's like 12 inches in a foot. So conversion factors are not counted with sig figs. Okay, and there's a reason for that. So what I mean by saying 12 inches is in a yard, I mean, oh my gosh, 12 inches is in a foot. Whew, jeez. We don't say that like the 12 has 2 sig figs and the 1 has 1 sig fig, because this is a known value. And this is more so going to influence when we actually do calculations with sig figs, but I want you to go ahead and write that one on your note paper, and then when we get to that later, we'll kind of revisit that idea. All right, so let's do some practice. As always with these videos, if you want to tackle the practice on your own, that is fine. So I would recommend pausing this video. I would always recommend pausing and trying stuff on your own, but if you are not confident, I will, of course, just go through these practice problems. So, okay, so number 1, I didn't write the instructions, but number 1 says count the sig figs. Okay, so in letter A, leading zeros are not significant, so that 0.0 is not significant. The 5, the 7, and the 3 are, though, and the 0 is trailing with a decimal, so this number has 4 sig figs. In part B, they're all leading zeros, which are not significant, only the 7 and the 3, giving me 2 sig figs. In letter C, all 4 are non-zero numbers, so this has 4 sig figs. And in letter D, the 4 and the 7 absolutely, and the zeros are sandwiched. So this number has 5 sig figs. Okay, in number 2, it's the same instructions, count the sig figs. So letter A, again, easy, 3 non-zero numbers, so 3 sig figs. Letter B, I'm going to use my scientific notation rule that we just learned, count the digits. So 1, 2, 3, and 4, it has 4 sig figs. If you don't believe me, take it out. Oops, that was just one move, wasn't it? Yep. So it would be, oh gosh, it would be 875.0, and that 0.0 is significant. So yes, it does have 4 sig figs. Okay, that rule works every time, I promise. Letter C only has leading zeros, giving me the 7 and the 4, so 2 sig figs. And letter D has a sandwiched 0, so all of them are significant with 4. All right, here's where life gets a little bit trickier. So number 3 says round off each answer to the number of sig figs in parentheses, and then write your answer in scientific notation. All right, so in letter A, I have 6 sig figs, and I only want 4. So what we're going to do is we're going to underline the first 4, which are the ones that I'm interested in keeping. And basically, all we have to decide is if that 5th digit does anything to the 9. Like, does it round it up? Does it round it down? Anything of that nature. And my pen just died, so I will pause this video and we will come back momentarily.